Alright, welcome back to our unit on lines and triangles. This is day 8, isosceles triangle theorem. Just kind of referencing the parts of an isosceles triangle. Please remember that the angle joining the two legs, which are the congruent sides, would be called the vertex angle. The base is the non-congruent segment, and connected to the base would be the two base angles. And your base does not necessarily have to be the bottom of the figure. Alright, let's go ahead and move right along into our one and only proof today. And that's given an isosceles triangle that segment AB is congruent to segment BC. We're going to prove that angle A is congruent to angle C. Now, this is the other time where I'm going to create an auxiliary line. Something I don't really expect y'all to be able to do in your proofs yet. Y'all just aren't there. But it says construct segment BM such that M is the midpoint of segment AC. And we are allowed to put in helpful lines, let's call them, as one student called them, to help us with the proof. This is called an auxiliary line. I'm actually able to create that through any 2 points. There's exactly one line that I made M the midpoint and point B. So I've got exactly one line. There's my auxiliary line. Hopefully you use a straight edge to draw yours out a little bit better. Let's prove that angle A is congruent to angle C. The reason why I made the auxiliary line is because now I have two congruent triangles, the one on the left and the one on the right, and I can actually make those triangles congruent. To start with, I'm actually going to say that segment is congruent to itself. That segment BM is congruent to segment BM by the reflexive property. And there I've got that written in. I'll go ahead and mark that as well. So if I sketch out all my ways to prove that triangles are congruent yet again, I'm actually able to get rid of a few right off the bat here after I've gotten to that step. I don't have a right angle, not going to be hypotenuse leg. I do have two pairs of sides, so it's going to be either side, 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 or side, angle, side. Since there's two pairs of sides it's shown to be congruent, it's not going to be angle, side, angle, or angle, angle, side. Let's take a look at what it is. And the key is the midpoint. That M is the midpoint of segment AC, so that tells me for statement number 4 that segment AM is congruent to segment MC by midpoint theorem. Alright, once I've got that there, I'm going to draw that out on my diagram using 3 tick marks there. Now the two triangles are congruent by side, side, side. That 3 pairs of sides are congruent, so the two triangles are congruent. Let's go ahead and name those triangles. If I call the first triangle ABM, I would have to call the second triangle CBM, so that the parts match, the segments match that we've already shown congruent. AB matches CB, BM matches BM, AM matches CM. And this is by side, side, side postulate. But once I've got there, look at what I was trying to prove, that angle A is congruent to angle C. And now see that angle A and angle C are corresponding parts of congruent triangles. So I'm able to wrap up my proof here that angle A is congruent to angle C since corresponding parts of congruent triangles are congruent. And that wraps up my proof. This is actually the proof that we're going to use quite a bit today, and this is called the isosceles triangle theorem. So the isosceles triangle theorem is that proof that we just did, and there are different ways to prove it. I could have made an auxiliary line that was a perpendicular bisector in other ways, and it works out just the same. But that's one way to prove it. The isosceles triangle theorem is in black right there. It says if a triangle is isosceles, then its base angles are congruent. No matter what. If it is isosceles, then its base angles have to be congruent. Now, the converse is also true, and the difference for the converse is whenever we switch that around, if a triangle's base angles are congruent, then it is isosceles. That's slightly different, saying if I have a triangle and I know information about its base angles being congruent, I can now conclude that this is isosceles. That's the reason why we're calling it the converse. We're swapping the hypothesis and conclusion there. Both of these are really good information for your notes. So moving right along, that triangle ABC is isosceles with base AC, and tells you what AB, BC, and AC all equal. We're going to determine the measure of AC. Since AC is what the base is, without even seeing the diagram, I can make the conclusion that AB and BC are my two legs for the triangle, And they have to be equal. If they're the two legs, they're going to be equal. The base is the non-congruent part. So hopefully you're comfortable with how I come to that conclusion, that AC is the non-congruent side, so the other two sides are congruent. Now I can substitute in the 2x plus 5 and the 4x plus 1 that it gave us. And now I'll just solve for x. I'm going to subtract 2x to the right here, subtract 1 over, and divide by 2. So x equals 2. It did say determine the measure of AC, so since AC equals 3x, 3 times 2 is 6. And we're done with that problem. Easy as that. Alright, this is going to wrap up today's class on this. When I'm looking at this triangle, I'm actually able to do this by using that isosceles triangle theorem. That didn't come up on the last example, but it does right here. That since I have 108 degrees, I can actually make conclusions about this triangle over here. Not so much this triangle over here yet. I don't have any of the angle measures for it. All I have is just this angle here, and that's just not enough. Going back over here though, since I'm finding x, I'm going to throw in a little bit of a y degree right here, just to help me with the problem. I know that since this is y degrees, this over here is also y degrees. And that's using the isosceles triangle theorem, knowing that the base angles are congruent. So now I know that y plus 108 is equal to 180. I just used triangle angle sum theorem right there. You need to be familiar with the names of your theorems. Solving for y right here, I'm going to go ahead and combine like terms. I'm going to subtract the 108 from both sides and get 2y is equal to 72, so y is 36. And that helps tremendously set up my problem now. Now I'm going to go back up to my diagram, get rid of what I drew in right there, and call this now 36 degrees. And that helps a lot because now I can quickly find this angle right here by taking the 36 and the 80 degrees off of 180. This is using supplements theorem. These three angles together make a line. So I'll be able to do 180, take away 80, and take away 36. 180 take away 80 is 100, and 100 take away 36 is 64. So this is 64 degrees. And now the rest of this problem is actually pretty easy. What I'm going to do now is this is another isosceles triangle over here, so I'm going to use isosceles triangle theorem yet again to know that the base angle on the right is also 64 degrees. And now I can set my problem up as such. I'll do x plus 64 plus 64 equals 180. So the two base angles added to 180, or excuse me, this is triangle angle sum theorem that I just did. The three angles of the triangle added to 180 degrees. I'm going to combine the two 64s to make 128. And when I subtract the 128 from 180, I get 52 degrees. And there's my final answer. So this is using isosceles triangle theorem on this problem. Hopefully this all made sense. Let me know what questions you've got. Don't forget that we're going to have our review for the next class and our test on Friday for this one. All right, folks. Appreciate it.